Hello. This chapter 7 problem and exercise is number 22. Apparently, when I recorded it, the recording equipment wasn't working, so I've been posting this silent movie, and I haven't had the opportunity to get back into lab and record myself doing this problem again, so here I am weirdly dubbing my voice on top of me weirdly talking about the problem. But here's the deal. We're talking about this train. It has kinetic energy. So the work that is done on the train is changing its kinetic energy from its initial value to 0. So it has a huge mass. I guess I can point on here. Has a huge mass. So work equals 1/2 mv squared. 1/2 times the huge mass times the velocity change. Velocity final minus velocity initial. So it's negative work that's being done on the train, negative 62,500 joules. It's a huge change in its kinetic energy. That is the work that is being done on the train to bring it to rest. Now, the second part of the problem, that work is being done by a spring. The train is crashing into a spring, which is then compressing. We were given a distance, 0.4 meters, for that spring to compress. So work equals 1/2 kx squared. That's the work that's being done by a spring. What we were asked to find is k, the spring constant. So rearranging this algebraically, work equals 1/2 kx squared. K equals 2 work divided by x squared. So 2 times that 62,500 joules divided by 0.4 meters squared, and we get this huge value. The spring constant is what you would get if you did force divided by distance. So we have an explanation for where the spring constant comes from, but rather than do that, we just kind of figured out what the spring constant is in this case. So the two equations that we're interested in, work equals the change in kinetic energy. So for the train itself, work equals change in 1/2 mv squared. Since the final velocity is 0, that one was pretty easy. And then the second equation is there's another definition for work done by a spring, work equals 1/2 kx squared. And then since we're solving for the spring constant k equals 2 times the work divided by x squared. So that's this problem. Now there's sound to go with it. And I will shut this off now.